And now in this lecture, we'll find out the radius of a circle. In the drawing, we have a circle. Inside this circle, we have chord dB that equals to 2 units in its length. This is called AC, that is equals to the square root of 2 units in its length. This is angle DEB, that is equals to 45 degrees. And our mission is to find out the radius of this circle. So first of all, we will join points A and D together by a straight line. By joining points A and D, we create that here by triangle BAD. This is peripheral angle BAD. We will define the size of this peripheral angle BAD as x over 2. Peripheral angle BAD is subtended on chord DB. Again, peripheral angle BAD subtended on chord DB. We will define the center of this circle, this point, as point O. In the next step, we will join points O and D together by a straight line. Likewise, we will join points O and B together by a straight line. Now, doing this construction, we actually created here central angle DOB. This is central angle DOB. And this central angle DOB is also subtended on the same chord called DB. Again, central angle DOB is subtended on chord DB. Now we can implement here rule 13. I'll repeat quickly on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing, we have a circle. Inside this circle, we have this peripheral angle ACB. The size of this peripheral angle ACB is theta, and peripheral angle ACB subtended on chord AB. This is peripheral angle central angle AOB, and this central angle AOB is also subtended on the same chord called AB. And therefore, according to this rule 13, the size of this central angle must be twice as large as the size of this peripheral angle, because both of them are subtended on the same chord called AB. The size of peripheral angle ACB is theta, and therefore the size of this peripheral and the size of this central angle AOB must be equal to 2 theta, because it is also subtended on the same chord called AB, exactly like peripheral angle ACB. So the size of the central angle AOB that is subtended on the same chord called AB is equals to 2 theta, twice as large as this peripheral angle that is subtended on the same chord called AB. So we can actually implement rule 13 in our drawing. Why? Because in our drawing those two angles, they are both subtend on the same chord called BD. And we know that according to our definition, peripheral angle, this is peripheral angle DAB. The size of this peripheral angle DAB is x over 2, therefore the size of this central angle DOB that is subtended on the same chord called DB must be equal to x. According to rule 13, of course. In the next step, we will define the size of this peripheral angle ADC. The size of this peripheral angle is y over 2. So this is peripheral angle ADC, and this peripheral angle ADC is subtended on chord AC. In the next step, we join points O and A together by a straight line. Likewise, we join points O and C together by a straight line. By doing this construction, we create in there central angle AOC. This is central angle AOC, and this central angle AOC is also subtended on the same chord called AC, exactly like this peripheral angle ADC. So those two angles, they are both subtended on the same chord called AC, and therefore, according to rule 13, the size of this central angle must be twice as large as the size of this peripheral angle, that is y over 2. Therefore, the size of the central angle must be equal to y. Okay. In the next step, I will copy triangle AED in a new page, and we will implement rule 4 on this triangle AED. So we copy the green triangle AED in the new page, and we will implement rule 4 in this triangle AED. Actually, this is triangle AED that I call it from the original drawing. Okay. This is again EAD. The size of this angle EAD is x over 2, and the size of this angle EDA is y over 2. Those two angles, they are defined as the is the interior angles of this triangle AED, while they are located inside triangle AED. So I write it down. Those two angles are both defined as the interior angles of this triangle AED. This is also angle AED, is also an interior angle of triangle AED because it is located inside triangle AED. While this is angle DEB, angle DEB is equal to 45 degrees in size. It is defined as an exterior angle of this triangle AED because it is located outside triangle AED. So I write it down. This is the exterior angle of triangle AED. So this triangle AED has three interior angles, x over 2, y over 2 in this angle AED, and it has also the exterior angle BED. The size of the exterior angle BED is 45 degrees. Okay, so in the next step, I will present to you all four, and we will implement all four in our drawing. According to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three interior angles, A, B, and C. They are all the interior angles of this triangle ABC. And this is angle E. It is defined as an exterior angle of this triangle. According to all four, the size of the interior angle E is equal to the sum of the two interior angles that are not adjacent to it. This is angle C, and angle C is adjacent to angle E. The other two interior angles that are not adjacent to angle E are A and B. And the sum of those two angles is of course A plus B. And according to this rule 4, the size of the exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. That is to say, it is equal to A plus B. Again, angle E equals to A plus B according to this rule 4. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have this is the interior angle BED. According to rule 4, the size of the interior angle BED is equal to the sum of the two interior angles that are not adjacent to it. This angle AED, is adjacent to angle BED. And the other two angles that are not adjacent to the other two interior angles that are not adjacent to this angle BED are those two angles, y over 2 and x over 2. So according to rule 4, the size of this exterior angle BED equals to the sum of the two interior angles that are not adjacent to it. That is to say, it is equal to x over 2 plus y over 2. So write it down. We actually found out that the size of the exterior angle BED is equal to the sum of the two interior angles that are not adjacent to it. That is to say, it is x over 2 plus y over 2. Okay, again, according to rule 4, the size of the interior angle BED is equals to the sum of the two integrals that are not adjacent to it. The two integrals that are not adjacent to it are x over 2 and y over 2. And the sum of those two integrals are of course x over 2 plus y over 2. So we found out that according to rule 4, the size of the hexagonal BED is equals to x over 2 plus y over 2. But it is given as the question that the size of the hexagonal BED is 45 degrees. So we substitute BED by 45 degrees. So 45 degrees equals to x over 2 plus y over 2. So here we multiply this equation by 2 and you get that 45 degrees times 2 is 90 degrees. So 90 degrees equals to x over 2 times 2 is x and y over 2 times 2 is y. So in conclusion, we found out that x plus y equals to 90 degrees. Here we subtract x from this equation and we get that angle y equals to 90 degrees minus x. So according to equation 1, angle y equals to 90 degrees minus x. In the next step, I repeat on the law of cosines quickly, and we will implement the law of cosines in this triangle, triangle BOD. Okay. The law of cosines is true in any triangle. So in any triangle, we have here triangle ABC that could be any triangle. The side and the length of side AB is A. Side AC equals to B which is in its there. This is side BC, this equals to C which is in its there. According to the law of cosines, the following equation will be true. We know that angle BAD, the size of this angle BAD is theta. So according to the law of cosines, the following equation is true, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So in the next step, I'll copy this triangle BOD in the new page, and we will implement the law of cosines in this triangle BOD. But before that, what is the definition of line segment OD? Line segment OD starts from point O, that is the center of this circle, and that's at point D, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OD is the radius of this circle. We define the radius of this circle as R, therefore OD equals to R. Likewise, OB will be also equal to R. OC will be also equal to R. And finally, OA will be equal to R. So now I'll copy triangle ODB in the new page, and we will implement the law of cosines in this triangle ODB. So here This is triangle OBD, this is the point from the drawing. Side, this is side DB. Side DB equals to 2 units in itself. Side DO equals to R, and side OB also equals to R. And this is angle X. According to the law of cosines, cosine X equals to OB squared. OB is R, therefore OB squared is R squared, plus OD squared. OD is R, therefore OD squared is R squared, minus dB squared. dB is 2, therefore dB squared is 2 squared, that is 4, so it is minus 4, divided by 2 times dO. dO is R, so we substitute dO by R, so it is 2 times R, times OB. OB is also R, so we substitute OB by R, and we get that total, the denominator of 2 times R times R. So according to equation 1, cosine X equals to R squared plus R squared is 2R squared. So in total, in the numerator we have 2R squared minus 4, divided by 2 times R, that is 2R squared. So cosine X equals to 2R squared over 2R squared is 1, and also minus 4 over 2R squared. So cosine X equals to 1. Here we divide both the numerator and the denominator of this expression by 2, and get that minus 4 over 2 is minus 2, and 2R squared over 2 is R squared. In conclusion, we should find out that according to equation 1, cosine X equals to 1 minus 2 over R squared. In the next step, I copy this triangle AOC in a new page, and implement the law of cosines in the triangle AOC. Side AC equals to the square root of 2 units in its name. So actually triangle AOC, and side OC equals to R, it is the radius of the circle. Side OA also equals to R. This is angle AOC. The size of angle AOC is Y. So actually, this is triangle AOC, this is the correct original drawing. So the next step, we'll implement the law of cosines in this triangle AOC. So according to the law of cosines, in this triangle AOC, cosine y equals to OA square. OA is R, therefore OA square is R square, plus OC square. OC is also R, therefore OC square is R square, minus AC square. AC is square root of 2, therefore AC square is square root of 2 square, that is 2, so it is minus 2, divided by 2 times AO is R, times OC, OC is also R. So in total, in the denominator we have 2 times R times R. So cosine y equals to R square plus R square. R square plus R square is 2R square, minus 2, divided by 2 times R is 2R square. 2R square over 2R square is 1, and we have also here minus 2 over 2R square. So cosine y equals to 1. Here we divide both the numerator and the denominator of this expression by 2. And we get that minus 2 over 2 is minus 1, and 2R square over 2 is R square. So in conclusion, actually found out that according to equation 2, cosine y equals to 1 minus 1 over R square. We already found out that y equals to 90 degrees minus x. So I'll write it down. We already found out that y equals to 90 degrees minus x. So now we substitute y in this equation 2, by 90 degrees minus x. And we get that cosine y is cosine 90 degrees minus x is equals to 1 minus 1 over R square. Repeat again, according to equation 2, we actually found out that cosine 90 degrees minus x equals to 1 minus 1 over R square. We have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So according to this trigonometric identity, you can substitute cosine 90 degrees minus x in this equation 2 by sinus x. We do it now, and we get that here, according to equation 2, we have cosine 90 degrees minus x. And cosine 90 degrees minus x, according to this trigonometric identity, is sinus x. So sinus x equals to 1 minus 1 over R square. This is according to equation 2. While according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. Again, according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. In conclusion, we have actually the value of sinus x in terms of r, and we also here in equation 1 the value of cosine x in terms of r. So in the next step we use the trigonometric identity that states that sinus square x plus cosine square x equals to 1. So in this trigonometric identity, we will substitute sinus x in this trigonometric identity by 1 minus 1 over r squared, because sinus x equals to 1 minus 1 over r squared, and also we substitute cosine x in this trigonometric identity by 1 minus 2 over r squared, because 1 minus 2 over r squared equals to cosine x. We will do it now. In this way we create equation 3. According to equation 3, we have in this trigonometric identity sinus square x. So according to equation 1, sinus x equals to 1 minus 1 over r squared. If sinus x equals to 1 minus 1 over r squared, it means that sinus square x will be equal to 1 minus 1 over r squared plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared, and it is equal to 1. Okay, so according to equation 3, 1 minus 1 over r squared plus 1 minus 2 over r squared equals to 1. Actually, in equation 3 we just substituted sinus square x in this trigonometric identity by 1 minus 1 over 1 minus 1 over r squared, and substituted cosine square x in this trigonometric identity by 1 minus 2 over r squared, and it equals to 1. Okay, so in the next step we define t as 1 over r squared, and we substitute 1 over r squared in this equation 3 by t. We do it now, we get that. So in equation 3 we have 1 minus 1 over r squared. 1 over r squared is t according to our definition, so we substitute 1 over r squared in this equation 3 by t. So this expression in total will be equal to 1 minus t squared plus we have here 1 minus t over r squared. 1 minus t over r squared is 1 times 1 minus 2 times 1 over r squared. We can multiply this expression by 1. We can actually multiply any expression by 1. By multiplying the expression by 1, we will not change the value of the expression. So this expression equals to 1 minus 2 times 1 over r squared, so it is 1, and we have minus 2 times 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared in this equation 3 by t. So in total, this expression will be equal to 1 minus 2t squared, and is equals to 1. So if we found out that 1 minus t squared plus 1 minus 2t squared equals to 1. We'll open the brackets on this side of this equation, equation 3, and we get that 1 minus t squared equals to 1 squared plus t squared minus 2t, and we have also 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, minus 2 times 1 times 2t is minus 4t, equals to 1. So actually, after we open the bracket on this side of this equation 3, we actually found out that one plus t squared minus 2t plus 1 plus 4t squared minus 4t equals to 1. So here we have 1 on both sides of this equation 3, so 1 we get cancelled. So after we cancelled 1, in this side of equation 3 we have t squared plus 4t squared is 5t squared, and we have also minus 2t minus 4t is minus 6t, plus 1 equals to 0. So we found out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say, five t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. So the only thing that is left to do is to put the data of our specific quadratic equation, that is to say this data inside the general formula for x, and in this way we find out the value of the values of t, because x equals to t. We do it now, and we get that here x equals to t, so we substitute x by t, and we get that t equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36. Minus 4 times a is 5, so minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. a is 5, so a is 2 times 5, that is 10. So in conclusion, we have found out that t t equals to 6 plus minus. Inside the root we have 36 minus 20, 36 minus 20 is 16, so inside the root we left only with 16 divided by 10. So I can found out that t equals to 6 plus minus, and the square root of 16 is 4 divided by 10. So repeat again, I can find out that t equals to 6 plus minus 4 over 10. Okay, so t equals to, here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1 from one side, but from the other side, according to our definition, t equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We do it now, we get that 1 over r squared equals to 1. So here we multiply this equation by r squared, and we get that r squared equals to 1. So here we take a root of this equation, and finally we get that the radius r equals to the square root of 1, that is 1. So according to the first solution for t, the radius r of this circle is equals to 1. But it is actually impossible that the radius r of this circle equals to 1. Why? Because in the drawing we have here chord dB, and chord dB equals to 2 units in its length, and chord dB is definitely not the diameter of the circle. So I write it down. According to what is given as the question, chord dB equals to 2 units in its length, and it is very clear from the drawing that chord dB is not the diameter of the circle. Chord dB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. The diameter of our circle is 2r. So the diameter of our circle, that is 2r, must be greater than dB, that is not the diameter of the circle. dB is 2. Again, the diameter 2r, this is the longest chord in the circle, must be greater than dB, that is not the diameter. dB is 2. So from this equation 2r greater than dB equals to 2, we will derive that 2r is greater than 2. 2r is greater than 2. We will divide this inequality by 2, and finally we will get that the radius r of our circle must be greater than 1. So if we found out that the radius r of this circle must be greater than 1. If the radius r must be greater than 1, the radius r cannot be equal to 1. So we cancel the solution. This solution is a correct solution. And we take into account only the second solution for t. The second solution for T is as follows. The second solution for T is T equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution, we have found out that T equals to 1/5. From one side, but from the other side, according to our definition, T equals to 1 over r squared. So now we can substitute T in this equation by 1 over r squared. We'll do it now, and we get that 1 over r squared equals to 1/5. 1 over r squared equals to 1/5. So here we'll cross multiply this equation, and we get that r squared equals to 5. Here we'll take a root out of this equation, and finally we get that the radius r that we're looking for, the radius r of the circle, is equals to either the square root of 5 units in itself, or in terms of numbers, it is equals to 2.236 units. So repeat again, we should find out that the radius r of this circle equals to either the square root of 5 units in itself, or in terms of numbers, it is equals to 2.236 units. So in the next step, I'll summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have a circle. Inside this circle, we have chord DP that equals to 2 units in its length. Chord AC equals to the square root of 2 units in its length. And this is again DEB. The size of again DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So the first step, we join points A and D together by a straight line. Repeat again. We join points A and D together by a straight line. By joining points A and D, we can do peripheral angle DAB. This peripheral angle DAB is subtended on chord DB. Again, peripheral angle BAD is subtended on chord DB. We define the size of this peripheral angle DEB as x over 2, and then we define the center of this circle, this point as point O. The next step, we join points O and D together by a straight line, and we join also points O and B together by a straight line. By doing this construction, we get the center angle DOB. This is center angle DOB, and center angle DOB is also subtended on the same chord called DB. Exactly like peripheral angle DAB, it is also subtended on the same chord called DB. So those two angles, they are both subtended on the same chord called DB. This is the peripheral angle and this is the center angle. So now we can implement here rule 13. So I repeat quickly on rule 13. According to rule 13, the center angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and this is peripheral angle ACB. Peripheral angle ACB subtended of chord AB, and the size of this peripheral angle ACB is theta. Likewise, we have also here central angle AOB. This is central angle AOB, and it is also subtended on the same chord called AB. So those two angles are both subtended on the same chord called AB. This is a central angle, and this is a peripheral angle. And according to this rule 13, the size of the central angle must be twice as large as the size of this peripheral angle if they are both subtended on the same chord. Again, the size of the central angle will be always twice as large as the size of the peripheral angle that is subtended on the same chord. So those two angles are both subtended on the same chord called AB, and peripheral angle ACB equals the size of peripheral angle ACB is theta, and therefore the size of the central angle AOB that is subtended on the same chord called AB must be equal to 2 theta. Okay, so if we can implement rule 13 in our drawing. Why? Because in our drawing we have those two angles that are both subtended on the same chord called DB. This is peripheral angle DAB, and this is the central angle DOB. And according to rule 13, the size of this central angle DOB will be twice as large as the size of this peripheral angle DOB, because both of them subtended on the same chord called DB. The size of peripheral angle DAB is x over 2, and therefore the size of central angle DOB must be equal to x over 2 times 2, that is x, according to rule 13. In the next step, we defined the size of this peripheral angle CADC. We define the size of this peripheral angle ADC is pi over 2. And then we join points O and C together by a straight line, and we join points O and D together by a straight line. This is peripheral angle ADC, and it's subtended of chord AC. Likewise, this is central angle AOC, it is also subtended on the same chord called AC, and therefore according to rule 13, the size of this central angle AOC must be twice as large as the size of this peripheral angle ADC. Why? Because of the fact that both those two angles are subtended on the same chord called AC, and the size of this central angle the size of this is peripheral angle ADC, the size of this peripheral angle ADC is y over 2, and therefore the size of this central angle AOC that is subtended on the same chord called AC must be equal to y over 2 times 2, that is y, according to rule 13. Okay. In the next step, I copied the green triangle DEA in a new page, and we implemented rule 4 of this green triangle DEA. So okay, this is the green triangle DEA. This is a copy from the original drawing. This angle EAD is equals to x over 2. This angle EDA equals to y over 2. Those two angles are both defined as the interior angles of this triangle DAE. Why? Because they are located inside triangle DAE. While this is angle DEB, it is located outside triangle DEA, and therefore it is defined as an exterior angle. So now we can implement rule 4 on this drawing. I'll repeat quickly on rule 4. According to rule 4, the exterior angle of a triangle is equals to the sum of the two interior angles that are not adjacent to it. So in the drawing we have triangle. Inside this triangle we have angles A, B, and C. All those three angles are defined as interior angles of this triangle because they are located inside the triangle, while this is angle E that is located outside the triangle, and therefore it is defined as an exterior angle. And according to this rule 4, the size of this exterior angle E equals to the sum of the two interior angles that are not adjacent to it. This is angle C. Angle C is adjacent to angle E. And the two other angles that are not adjacent to angle E are A and B. And according to this rule 4, the size of angle E is equals to A plus B. Again, E equals to A plus B, and A plus B is the sum of the two angles that are not adjacent to angle E. So if we're going to actually found out that angle E equals to A plus B. So we can implement rule 4 in our drawing. Why? Because in our drawing we have triangle DEA, and those two angles x over 2 and y over 2, they are both defined as interior angles. And this is angle BED, it is located outside triangle DEA, and therefore it is defined as an exterior angle. According to rule 4, the size of the exterior angle BED will be equal to the sum of the two angles that are not adjacent to it. This angle is adjacent to angle BED, and the two other angles that are not adjacent to angle BED are y over 2 and x over 2. And therefore, according to rule 4, the size of angle BED equals to x over 2 plus y over 2. That is the sum of the two angles that are not adjacent to this angle BED. So repeat again, actually found out that according to rule 4, the size of the interior angle BED is equals to x over 2 plus y over 2. But it is given as a question that the size of this exterior angle BED is 45 degrees. So we can solve BED by 45 degrees. And we get that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2. And finally found out that 45 degrees times 2 is 90 degrees, x over 2 times 2 is x, and y over 2 times 2 is y. So in conclusion, we found out that 90 degrees equals to x plus y. We subtracted x from this equation and finally found out that y equals to 90 degrees plus 6. Okay. In the next step, I presented to you the law of cosines, and we implemented the law of cosines in this triangle BOD. So please click on the law of cosines. According to the law of cosines, first of all, the law of cosines is true in any triangle. So we have this is triangle ABC that could be any triangle. This triangle ABC, the length of side AB is A, side AC equals to B units in its length, and side BC equals to C units in its length. This is angle BAC, the size of angle BAC is theta. So according to the law of cosines, this triangle ABC that could be any triangle, the following equation will be true. That cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So we can actually implement all the law of cosines in any triangle, and especially in triangle DOB. So I covered this triangle DOB in a new page, and we implemented the law of cosines in this triangle DOB. But before that, we know that all the four segments OD, OB, OC, and OA, they are there of this circle that equals to R. So all of them, each of them is equals to R. This is the area of the circle. So I copied this triangle ODB, I copied it from the original drawing, and here we have side OD and side OB, they are both the area of the circle that is equal to x, and it is given as the equation that DB equals to 2, and this is angle x. According to the law of cosines, the following equation will be true, that cosine x equals to OD squared. OD is R, therefore OD squared is R squared, plus OB squared. OB is R, therefore OB squared is R squared, minus DB squared. DB is 2, therefore DB squared is 2 squared, so it is minus 2 squared is 4, so it is minus 4. Divided by 2 times OD, that is R, times OB, that is also R. So in total, in the denominator we have 2 times R times R. So according to equation 1, we should find out that cosine x equals to r squared plus r squared minus 4 over 2 times r times r. R squared plus r squared is 2r squared. So in total, in the numerator we have 2r squared minus 4 divided by 2 times r is 2r squared. So, and here we have 2r squared over 2r squared is 1. And we also have here minus 4 over 2r squared. Here we divided both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2r squared over 2 is r squared. So in conclusion, we should find out that according to equation 1, cosine x equals to 1 minus 2 over r squared. In the next step, I copied triangle AOC in a new page and implemented the law of cosines in this triangle AOC. So actually, this is triangle AOC that I copied from the original drawing. Side AO equals to side CO. They are both the area of the circle that equals to R. The side AC equals to the square root of 2 units in itself according to what is given in the question. And angle AOC, the side of angle AOC is y degrees. So according to the law of cosines in this triangle AOC, the following equation will be true, that cosine y equals to AO squared. AO is R, therefore A squared is R squared, plus CO squared. CO is also R, therefore CO squared is R squared, minus AC squared. AC is square root of 2, so AC squared is square root of 2 squared, that is 2. So it is minus 2 divided by 2 times AO is R, times CO, that is also R. So in total, the denominator will be 2 times R times R. So conclusion, according to equation 2, I should find out that cosine y equals to r squared plus r squared minus 2 over 2 times r times r. R squared plus r squared is 2r squared. So in total, in the numerator of this expression, we have 2r squared minus 2 divided by 2 times r is 2r squared. So here we have 2r squared over 2r squared is 1, and we have also minus 2 over 2r squared. So here we have we divided both the denominator and the denominator of this expression by 2, and we have here minus 2 over 2 is minus 1, and 2r squared over 2 is r squared. So in conclusion, we should find out that according to equation 2, cosine y equals to 1 minus 1 over r squared. This is according to equation 2, but we already found out that y equals to 90 degrees minus 6. So therefore we can substitute y in this equation 2 by 90 degrees minus 6. We did it. So we should find out that according to equation 2, we have cosine y, and y is 90 degrees minus 6. So cosine 90 degrees minus 6 equals to 1 minus 1 over r squared. We have the trigonometric identity that states that sine of x equals to cosine 90 degrees minus 6. Therefore, according to this trigonometric identity, we can substitute cosine 90 degrees minus 6 in this equation 2 by sine of x. We did it and actually found out again that cosine 90 degrees minus 6 is sine of x. According to this trigonometric identity, sine of x equals to 1 minus 1 over r squared. This is according to equation 2. Or according to equation 1, we already found out that cosine x equals to 1 minus 2 over r squared. So we have here the value of sine of x in terms of r, and we also the value of cosine x in terms of r. The next step use the trigonometric identity that states that sine of square x plus cosine square x equals to 1. And according to equation 2, sine of x equals to 1 minus 1 over r squared. According to equation 1, cosine x equals to 1 minus 2 over r squared. If sine of x equals to 1 minus 1 over r squared, it means that sine square x will be equal to 1 minus 1 over r squared squared plus cosine square x. Cosine x equals to 1 minus 2 over r squared, therefore cosine square x will be equal to 1 minus 2 over r squared squared. and it is equals to r. It is equals to 1 according to this trigonometric identity. So according to equation 3, we shall find out that 1 minus 1 over r squared plus 1 minus 2 over r squared equals to 1. In the next step, we define t as 1 over r squared. So now we can substitute t, we can substitute 1 over r squared in this equation 3 by t. We did it, and we shall find out that according to equation 3, we have 1 minus 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared in this equation 3 by t. So this expression in total will be equal to 1 minus t squared, and we also plus 1 minus 2 over r squared. You multiply this expression by 1, so this expression will be equal to 1 minus 2 times t, because 1 over r squared is t squared. Again, this expression in total equals to 1 minus 2t squared, and it equals to 1. Here we open the brackets on this side of the equation 3, and we actually found out that 1 minus t squared equals to 1 squared plus t squared minus 2t plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared plus 2t squared, that is 4t squared, minus 2 times 1 times 2t is minus 4t equals to 1. So after we open the brackets of this equation 3, we shall find out that x1 plus t squared minus 2t plus 1 plus 4t squared minus 4t equals to 1. So here we have 1 on both sides of the equation. So 1 we get cancelled. After we cancel 1, in this side of the equation we left only with t squared plus 4t squared is 5t squared. We have minus 2t minus 4t is minus 6t plus 1 equals to 0. So we actually found out that 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and the coefficient c equals to 1. So the only thing that is left to do is to put the data of this specific quadratic equation in the general formula for x, and in this way we find out the value of the values of t, because x equals to t. X equals to t, so we substitute x by t, and we found out, okay, that t equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36. Minus 4 times a is 5, so minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20. So inside the root we left with 36 minus 20 divided by 2a. A is 5, therefore 2a is 2 times 5, that is 10. So if we found out that t equals to 6 plus minus, inside the root we have 36 minus 20. 36 minus 20 is 16, so inside the root we left only 16 divided by 10. The square root of 16 is 4. So if we found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1 from one side, but from the other side, according to our definition, t equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We did it, and actually found out that 1 over r squared equals to 1. We multiplied this equation by r squared, and we found out actually that r squared equals to 1. We took a root out of this equation, and finally found out that the values r is equals to the square root of 1, that is 1. So according to the first solution for t, we found out that the radius r of this circle equals to 1. But it is actually impossible that the radius of this circle r will be equal to 1. Why? Because of the fact that we know that this is called dB, that equals to 2, and called dB is definitely not the diameter of the circle. Again, it is given us the question that called dB equals to 2, and called dB is definitely not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. And therefore, the diameter of this circle is 2r. And so the diameter of 2r, that is the longest chord in the circle, must be greater than BD. This is not the diameter of the circle. And BD equals to 2. And from this inequality 2r is greater than dB equals to 2, we derive that 2r is greater than 2. Here we divide this inequality by 2 and finally found out that r is greater than 1. So if we found out that the radius of this circle is greater than 1. If the radius of this circle is greater than 1, the radius of the circle cannot be equal to 1. So this solution is a correct solution, so we cancel the solution and we'll take into account only the second solution for t. Okay? And the second solution for t is t equals to 6 minus 4 over 10. Okay, again, the second solution for t is the t equals to 6 minus 4 over 10. 6 minus 4 is 2 and 2 over 10 is 1/5. So according to the second solution for t, t equals to 1/5 from one side. But from the other side, according to our definition, t equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We did it. We also found out that 1 over r squared equals to 1/5. Because multiply this equation, we finally found out that r squared equals to 5. We took a root of this equation and finally found out that the radius r that we are looking for, the radius r of this circle equals to either the square root of 5 units in length, or in terms of numbers, the radius r of this circle is equals to 2.236 units. Okay, thank you very much.